You're listening to Behind the Wheels with Doug Mason, Dave Walters, and Mike Yeagley. This is a show where we talk about heavy truck and medium-duty axle-ends. Doug, Dave, and Mike bring close to 100 years of experience and expertise in the transportation business. Join us once a month to learn new things about axle-ends. Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation.
Welcome to another episode of Behind the Wheels. I'm Mike Yeagley.
I'm Doug Mason.
And I'm Dave Walters.
Today we have with us Roger May from ConMet, the National Service Manager. Hey, thank you for joining us, Roger.
Hey, thank you for this opportunity.
Let's start out with just your background. Where do you come from? Tell us a little bit about ConMet.
Hey, we'll start with my background.
Yeah.
I'll roll into ConMet.
That
Very
sounds
good.
I've been at ConMet, if I make May 2nd, 43 years. I spent 7 years in the foundry. I spent 16 years as quality manager in one of our large hub plants. And the last 21 years I've been on the road doing service. Training, trade shows, skills challenges, just, whatever the opportunity is, I'll raise my hand to go.
Great.
Perfect.
ConMet, been in business since 1964, started by a company that makes trucks to make aluminum castings. We started aluminum hubs in 1964. We've evolved since then to where we've got the full product offering, iron, aluminum, disc brakes, drum brakes. We make a lot of different things as a job shop for the industry. Plastic interior components, aluminum castings on the chassis, and our number one customer is Class 8 trucks.
Okay.
Beautiful. That's what we want to hear.
Go on, Dave.
And I was going to say, in our industry, when we come to TMC like we are this week, there are experts in each field, and Roger May is always known as the expert in the hub world. So thank you for joining us.
So I guess going back into some history then, you were telling us before we started this a little bit of history on the hub, the spindle, and how that all kind of got standardized and TMC's affected in all that.
Oh, yeah, that's kind of an interesting thing. They invented tapered roller bearings in 1898. Well, until 1993, 95 years, you basically adjusted it how you wanted. And techs learned by handed down information, and there was really nothing concrete to hand down. So in 93, TMC developed RP618, 8 steps, calibrated torque wrench, calibrated dial indicator. Follow the steps. The goal is to dial in 1 to 5 thousandths in play. And we test technicians in skills challenges multiple times a year, and they really struggle with that. So in 1995, the industry's changed. ConMet came out with what we call preset wheel ends. The industry calls it pre-adjusted. We control the length of the machining in the hub where the cups press in to a really precise number. We have what the industry calls a half-stand bearing, and we have a precision machine bearing spacer. The combination of the three of those gives us an assembly that we basically put on the spindle, torque the nuts to a given spec, set the lock, put the lube in. From there, periodic inspection for maintenance.
When I think of a bearing system, there's the inner bearing, there's the outer bearing.
Right.
How the loads are transferred to those inner and outer bearings is critical, right?
Right. With manual adjust, we dial in 1 to 5 thousandths in play using the torque wrench, the dial indicator, and the TMC 8-step procedure. And if we look at bearing and seal life, the optimum bearing and seal life is we target 0 to about 2 thousandths preload. Well, it's impossible to measure preload in the field, and so we've established for manual adjust the 1 to 5 thousandths range, which gives you a bearing life and a seal life that's acceptable. Well, the closer we get to 0 to that 2 thousandths preload, the better the bearing life and the seal life are. So preset targets 0 out of the box. And we give it a system that the technician just torques the spindle nuts, set the lock, and because of the manufacturing tolerance of the components, he doesn't have to do anything other than that. The adjustment's built in.
Just put it in and don't touch it
Right.
again.
And we target that optimum place for optimum bearing and seal life. And we came out with that with a system that would use double jam nut, one-piece spindle nut. We didn't care. We just wanted the clamp load. Well, we had this phenomenon in the industry that put all of us in a scramble with wide base tires and 2-inch outset wheels. And we saw some harmonics on the vehicle we hadn't seen before. We saw air brake chambers, air dryer brackets, S-cam tubes fatiguing and cracking. We saw some cone race rotation, and so the industry scrambled to address that. And we looked at derating vehicles because of the 2-inch outset wheels, some things that nobody really wanted to do, but that was the downstream. So we looked at changing the track on the axle so we don't have to derate anymore. That's been part of the evolution. And ConMet came up with a spindle nut that's actually built into the hub and provides better clamp, provides a good interface between our washer and the cone race of the bearing that helps keep that cone race rotation from taking place.
Okay.
You talked about a preset plus before we got online too here. Is that what you were just describing?
Right. That's a unique spindle nut that's part of the assembly built into the hub. It's the half stand bearings, it's the spacer, it's the precision machining of the hub, plus it's a unique spindle nut that becomes the shipping cap that holds it all together from the time you take it off the skid that we ship it to the truck or the axle plant with till it goes on the spindle. We slide it in place. We align the key in the keyway of the washer and the spindle nut assembly. We push forward. We catch the first thread. Well, at this point, the seal is not engaged the seal journal on the hub or on the spindle. So as we rotate that nut, we index the hub up onto the spindle, and we engage the seal in the seal journal. So everything is parallel, slides on smoothly. It keeps from cocking the seal and damaging the seal. So package unit goes out, we torque the nut, and one of the things that we find in testing, technicians are always concerned with, do I loosen the nut or do I tighten the nut to get the lock in? Well, in this case, with our spindle nut, there are 3 holes in the face of the nut. We torque it to the prescribed torque. We find the hole that fits, we put the locking ring in, and the assembly's completed. It's going to come away with a 5-year, 500,000-mile warranty on a tractor, 7-year, 750,000-mile warranty on the trailer. And that's a huge factor if you're the end user.
You know, my simplified understanding of the problems that were going on with the bearing life with those wide base wheels back in the day, this goes back probably, I don't know, 3, 5, 7 years, something like that.
Yeah, further back than that, 10 or 12 years when we really, when we really
time
started
flies
addressing
when you're having fun. Eh?
It does.
So basically what the way I always thought of it, and correct me if I'm wrong, I guess I'd love to be corrected. When you take a wheel and a tire, the middle of that tire, that's where the load line is.
Right. We set it up and we distribute the load between the 2 bearings, and that's part of the design factor that goes into the hub design. It's where we're centering that load.
Right.
And the derating, if you've got 1.13-inch offset or less, we don't have to derate. Well, the further out you move that load, the more you're loading the outer bearing, and the greater the derate is from that assembly. So the industry reacted very, very quickly. We came out with axles that took care of it. We got it back into 1.13 or less. The load ratings went back up to where they were to start with.
So what was happening back in the day, the fleets, they wanted to see that outer wheel, that outer dual, I should say, the outer face of the wide base, roughly as close as they could get to the old
to
width.
the original track with the dual.
The original track width.
Which would be 2-inch offsets.
That's where the 2-inch offset came from.
And the great thing about it is when TMC kind of knew about it, we, started to write an RP so we could adjust on this. So, I mean, and like Roger said, we even went a step further by doing the axles, but getting an RP out as soon as you could to say anything that's 1.13 or less can go on this axle, but if you're going to do a 2, here's where you...
Right, here's the derate.
Yeah.
And one thing kind of that I liked about the TMC reaction to this, we have 2 meetings a year where we do a lot of this work. We had a meeting between these meetings where a group of us got together, people that had a vested interest in this, and we said, hey, we need to react quickly, and we worked on that RP, and we got it out very quickly.
And again, we'll just put in another plug for those who are listening out there for TMC. If you're a fleet who is not involved or engaged, there's a lot of benefits. As you're saying, Roger, if there's issues in the field, they are addressed rapidly by TMC, and it's a good organization to be a part of.
Hey, this is where the information starts.
Yep.
And this is the information that everybody in the industry salutes. The biggest teaching tool I have is an RP, a recommended practice. And the reason it's so big is we know the things that have gone on behind the scenes, that everybody's got a chance to have input, everybody's got a chance to vote. And when it's approved, it's something everybody believes and salutes.
That's right.
Nobody second guesses an RP.
Well, there was a lot of work going on. That was one of the areas that I did get involved. I was working with our friends in the tire industry, our friends, some of the axle guys. Alcoa Wheels also had a place at the table with us, trying to work through these issues. I remember Phil Arnold from Michelin was deeply involved. That was my trial by fire. That's where I learned about bearings, was dealing with that issue. I hadn't really had much opportunity to get much into the bearing world prior to that. I don't know how bearing works when it's right, but I know when it's wrong.
Right. A lot of people got an education on things that we had taken for granted prior to that, and it made us look at some things that we had before, and the industry came way stronger because of it.
I think so, absolutely.
You brought up the warranty that you have on there for a 5-year or a 7-year
Right.
setup. What type of preventative maintenance or maintenance issues need to be taken care of during those 5 years? Is there much inspection that needs to be done? How is this handled in the field?
Very, very simple things. Driver pre-trip and a technician PM and some attention to detail when we're changing tires and changing wheels, got them off the hub. If we do some basic things, that thing's going to live a long time and give good service. But we miss some of these. We miss an opportunity to find a problem before it happens.
Can you enumerate the most critical things that they need to be looking at? Let's start with the driver walk around. Is there anything?
Driver pre-trip is really, really basic. It doesn't take a lot of time. We're looking at the lube level in the hub itself. And on a steer or a trailer lubricated with oil, we've got a sight glass in the hubcap. We want to keep it between the marks. We want to look for signs of contamination, moisture. It looks kind of like a butterscotch milkshake. It's got a milky appearance.
Once it's contaminated.
Once it's contaminated.
Yeah.
The thing is, it only takes 1 to 2% moisture to contaminate the lube. So with that, thank goodness it's got Telltale Signs, and we see what's going on just by the visual inspection. We like to look for dark or rusty streaks coming from the wheel bolts. That's a sign that we've got a potential loose fastener. That's one we want to look at. We want to look for broken or missing fasteners. If we break one fastener, we want to replace 3. We want to replace the broken one, the one on either side. If we break 2, we want to replace all 10. And we don't want an enterprising technician to take a sledgehammer and drive the stud out, put a new stud in, and stack some washers up, put a nut on it, and pull it in with the impact wrench.
Something tells me that happened once or twice.
Oh, it happens, absolutely. And so we want to take the thing off. We want to support the flange, press the stud in and out as it should be.
Okay, so that's the driver walk around. So now we're talking about PM. A little bit deeper dive to make sure that your hubs are okay.
We want to do everything that the driver does in the pre-trip. We want to look at the fasteners. We want to look at the lube. We want to look for signs of a seal leak. We want the wheels off the ground. We want to spin the wheel, free or smooth rotation. We want to listen for noise. We want to check for vibration. And that's as simple as putting your hand on the steering knuckle of the brake chamber when you spin the wheel. I like to put a magnet in the lube and see if I pick up any metallic particles.
Oh, that's a great idea.
That's a sign that I've got a potential failing bearings, peeling, spalling, something like that.
Wow.
With a driver or trailer hub, our company has gone so far to put a magnetic fill plug in the barrel of our Preset Plus hub. So you pull the fill plug out, it gives me a chance to look at the condition of the lube, to check for the moisture contamination, and I look at that magnet for signs of metallic particles. It gives me an indication I might have a bearing failure.
When you get into the lube, Roger, is there a maintenance interval that you need to change the lube? Or, I know there's synthetic and there's other types.
That is very subjective. And with the moisture contamination, it's very obvious. With semi-fluid grease that we see a lot in trailers, we've got the issue of how long has it been in there? What's the condition of it? Is it still suitable for use? And that's kind of subjective.
Do you have recommendations just from a time frame standpoint?
Annually, we want the hubcap to come off. We want to do a visual inspection. The condition and the quantity of the lube. Are the big end of the bearing rollers still covered?
Mm-hmm. Okay. And if they're not, obviously, address it.
Exactly.
Okay, I guess in the industry, Roger, ever since I was one of them that kind of grew up around trucks, and my granddad had them, and I worked on them, and I remember my first day, my granddad says, you just tighten them up, stop the wheel, back it off, and spin it around, and life is good. Okay, you've been around a long time in the industry, setting the preload. I know with all the stuff, but all the wise tales of, does any of that stuff add any merit at all?
RP 618 is the Bible on that.
Okay.
Techs learn one of 3 ways. They learn by talking to the old senior guy, they learn by reading the service literature, and they learn by making mistakes. And my product and your product, we can't afford to make a mistake on it. It can be catastrophic.
Right.
And so we do these basics, and we're in good shape.
The big thing is, and at least what I've seen in the industry, is that those techs, they learn with their fingers.
They're hands-on visual learners.
They're hands-on guys. And so they need to get in there and with that senior guy looking over their shoulder. That's the best way, I think.
Right. Well, to a certain point, sometimes the senior guy might not know the current way. So much is changing in this industry. Right. And if we look at what we've got out on the industry now, we see YouTube videos that are telling people how to do it. You go to the website, and you've got people that are telling you on the website, the way to do it. And it's a visual thing. That's going to be the wave of the future, I think.
Well, you can't count on those YouTube videos doing it right, though.
The problem is YouTube and the internet have no editor.
Right.
That's why you consider where you go, and you go to the equipment manufacturer, see what they've got posted. That's the information you believe.
So does ConMed have videos? And I'm sure they have material there on your website.
We've actually got an online hub training program where you can go to our website and call up the hub training program, broken down in segments. You take the segment, you take a little test. If you make 100, you move to the next. If not, you back up, retake the test till you get 100 on it. When you complete each segment, then you can print a certificate of completion.
Okay.
And so that's our online training, and we use that to supplement our one-on-one in the dealer, in the service shop training.
As you go out into the field and as you get calls in for concerns, what are the primary issues that you run into? What are the primary things that you have to deal with people doing incorrectly in the field?
You know, that varies from every phone call. And there's probably no one answer there that's right because I get so many simple things. The best part of it is people call to ask the question rather than trying to do it incorrectly. And that's the reason Dave and I are in the industry, and our phone numbers are out there. Call the factory service people. We want to help you. We have a toll-free customer service number, and they ask her a lot of the questions. They're the first call. If not, they find us, and we do a conference call to take care of it. The big thing I see is questions about spindle nuts, questions about identifying the wheel end, and TMC has had a section that we tried to identify wheel ends, and we basically had to agree to disagree that we didn't have a standard way of doing it. Well, I'm real proud of what we did with our Preset Plus product. We actually put the identification, we say ConMet, Preset Plus, 300 or 500 foot-pounds of torque, a steer torque's at 300, a drive and a trailer torque at 500, and we say red locking ring required.
And it's all right there.
It's on the face of the spindle nut. So,
all right.
So once you take the hubcap off, we tell you what you're working on, we tell you how to work on it, and the work instruction is built into the product.
So is it fair to say the most important thing is that driver walk around, take a look at the lube, take a look at the color of it, take a look at the level, and then, of course, the PM.
Yeah, look for seal leaks, just the basic visual things, and it's very, very easy to do. The next piece of the puzzle on the driver or the technician PM is check for chucking, and I ask about that, and people typically don't know what it is. One thing that ConMet and TMC disagree on, TMC says annually or 100,000 miles, we want you to measure the end play on the wheel end. Well, we think that's probably going to generate more problems than you're going to find. ConMet's going to tell you to check for chucking, and that is a matter of jacking the wheel up, take a pry bar and a place to leverage, put your hand on top of the tire, push down on the tire bar, feel for loose motion in the bearings. You'll feel the top of the wheel move as you apply the pressure to it.
It'll start to cock a little bit.
Yes, and you feel a little bit of a bump in the bearings. We call that checking for chucking.
Okay.
And if we feel that movement, that's the one I want you to measure end play on. And one caution, kingpin wear feels just like loose bearings. So if you're checking a steer hub and you get that little bit of loose motion, grease the kingpins. The grease is going to dampen the wear and the play in the kingpin, and it's going to make you just feel the wheel bearing. So grease the kingpin, and if it goes away, then you know you were looking at loose kingpins. If it stays there, that's the one I want you to measure. And we say above 0.006 of an inch, I want you to pull it apart, inspect it, find out what the issue is.
So basically what you want to do is keep them from touching that wheel bearing if they can help it. It's going to cause more problems than it's going to solve. You don't want to play with it, just,
Absolutely. The basics of inspection are really, really quick. And if your technician knows how to do this, you've got the wheels off the ground. Spin it. Check for noise, check for vibration, check for chucking. Put your magnet in the lube or pull the magnetic fill plug. Look at the condition, look at the quantity, look for signs of foreign material. We are good. The next step is after you've been driving, check the operating temperature of the hub. And that's as simple as walking around and laying your hand on it. If one is noticeably hotter than the other, that's the one we want to look at. Now, the question comes, how hot is too hot? We say ambient plus 150 degrees. So if it's a 75-degree day, I add 150. That hub should never operate over 225 degrees.
That's going to burn your finger.
That's going to burn your finger. But that's the rule of thumb.
But you'll know.
But you'll know.
You'll know. So
be ready when you're touching that thing. Be ready for that 220.
Oh, I got a good story on temperature just real quick. Just a sidebar. We used to work in a permanent mold shop Right, there you go. And so
Me
we did
too.
all kinds of die coating going on, and we had a gentleman who was years and years in the field, and he was teaching us how to do this properly. This was when I was a young kid. About 5 of us out there doing it. And so we said, well, how do you check the temperature? He goes, you need to be at this temperature. And I said, well, how do you check temperature? He goes, you just put your finger on it and touch it. Okay.
sure.
Oh, sure. I'm like, I ain't doing that. But one of the guys that was with me goes, oh, okay. And he puts his finger on this mold that just came out of the oven.
It left his fingerprint.
He left his
The whole
fingerprint.
end of his
and he
finger
jumped
on
off
there.
of there, and the old gentleman just started laughing. And he goes, what'd you have to do? And you look at his thumb. His thumb's got this callus. It's about a half-inch high. That he's been doing it for 30 years. He goes, that's how you tell it's hot enough. So
Well,
you got to be careful.
I'm a little more scientific than that. Infrared thermometer. Use the infrared thermometer. It's really, really easy. And if you find one that's noticeably hotter than the others, one that's above the range, that's the one I want to check. And with these simple things, I'm convinced we're going to keep wheels on trucks. We're going to be safe.
Well, see, when Doug told that story, I remember when I was a kid, and again, my granddad told me lots of wise tales. He'd say, take that rosebud, heat that bearing up. When the spit bounces off of it, it's ready to go. And I'm like, there's got to be a more scientific. No, that is what you do. And I'm like, okay. So, I mean, the wise tales are out there. Me and Roger lives them every day. The one question I got for you, Roger, aluminum hubs are really a big part of the market, especially on tractors. Do you see any difference between a steel hub and an aluminum hub, maintenance issues, or anything that general public or the technician should look at when they're dealing with one or the other?
You know, as far as function, they're doing exactly the same job. You put aluminum on, you save weight. Because of the physical properties of aluminum, there's considerations that we have to have. You be careful when you mate the wheels to the aluminum hub that we don't scrape the pilots on it. Across the board, whether it's iron or aluminum, we want to clean the mating surfaces. We want to clean the backside of your wheel. We want to clean both sides of the drum. We want to clean the mating surface on the hub itself. We want to clean the little step on the pilot where we seat the drum. We want to make sure that we've got all the foreign material off there. Our procedure is clock a pilot to 12 o'clock, seat the drum, seat the wheel, put the top bolt on, snug it up to hold everything in place, rest of the nuts on, starting at the top, in sequence, star pattern, 450 to 500 foot-pounds, final torque with a torque control device, and that is not an impact wrench.
Yeah.
We've had numerous discussions on that this week.
Yes, and
That's a favorite discussion for us wheel guys.
absolutely, and the hub side of it too. That's a favorite discussion for us because we can over-torque the thing, and it's probably
Yeah, you own those studs.
Yeah, hey, we own the studs. We can stretch the studs, and I've got a real seat-of-the-pants way to do that. When we've got the wheels off, take a new wheel bolt. Engage the threads of that wheel bolt with the threads of your stud. If they don't match up, that's one that's been over-torqued, and we call that necking.
That's a great
And
idea.
When Dave was in high school, he told me some necking stories, and it's
This is a little different.
this is different. This is not what made Dave smile here. We're worried about over-torquing that stud and stretching it to where the threads don't engage anymore, and we've got the potential for failure then.
And that's a real quick check. I mean, one of the things we've talked about in the past was taking a nut and walking it down that stud, but it'd be a lot faster to just take a
The
new,
same
a
thing.
new stud and check it. That you could do
Check
that real
the-
quick.
Hey, as quick as you can engage it, you can see if you've damaged that stud. And
Yeah.
so we're going to mate the thing up on clean surfaces. That's the critical portion. Clock the pilot to 12, seat the drum, seat the wheel. If we don't seat the drum and we have it off position, this is getting back to Dave's original question about aluminum hubs. If I torque a bottom bolt first, I've torqued things out of position. And as I torque the top bolt, it's going to shave the pilot on the aluminum hub. It's going to be a pinch point that's going to potentially crack the drum, potentially damage the wheel, and
Potentially cock the wheel, too.
yes,
right?
and
Yeah.
we've got
Down the
safety
road, you got a
issues,
problem.
we've got tire wear issues. But the thing about it, to do it right, is very, very simple. Pilot at 12 o'clock, seat the drum, seat the wheel, star pattern, torque control device, which is not an impact wrench. We want the final rotation of that nut with a torque control device. The piece of this that we preach, and Dave and I preach the same message, and it's a TMC message, retorque at 50 to 100 miles. We get this phenomenon called joint relaxation. We go down the road at speed with a load in a turn, and things kind of settle in. And my Canadian customers are much more religious about this because they have a potential of a $50,000 fine.
That's right.
If you lose a wheel
That's
on a
right.
public road, truck or trailer, $50,000 fine. they actually attach a tag to the dash of the tractor saying, driver, you've got to stop in 50 to 100 miles and have these bolts retorqued.
Okay.
And that's the piece that we preach in the United States, but the follow-through is not that good.
Right.
Unless you have a wheel off. And then I've got a customer with a new religion. He calls up wanting to know the right way to do it.
At least with us, we say about 5 miles or so with the aluminum wheel. But
okay.
I think 50 miles if you're going to do it.
Doing it.
As long as you're doing it.
As long as you're doing it,
Yeah.
doing it. In other words, let the joint relaxation take place. Let it do what it's going to do. Let it settle in and retorque. Now, I came up to Pennsylvania, Dave's old hometown, to a customer that says, I am cracking hubs. I need help. I fly up from North Carolina. I get my rental car. I drive into his parking lot, and I park 30 feet away from his first truck there, and I know immediately what he's done wrong. He has put anti-seize on the stud, the full length of the stud.
Yeah.
And I said, oh, my gosh, what did you do that for? He says, well, we've got all this calcium chloride up here. We're trying to keep ice off the roads, and says it's killing my trucks. And I put wheel bolts on that I can't get back off. So I put this anti-seize on so that will come back off.
Yeah. Oh,
well,
boy.
Unfortunately, it changes the coefficient of friction.
Yeah.
The spec is 2 drops of oil on the outer 2 or 3 threads, 1 drop of oil between the body of the nut and the washer on hub pilot.
And then work it in a little bit. Yep.
Torque it, everything's good. So with his anti-seize,
with his fix, he broke
his fix, and I don't know if he was using a torque wrench or if he's using an impact wrench. Bottom line was, it was enough force on that joint. He's breaking the flange off of the hub.
We were talking to a guy here.
Breaking the flange right off the hub.
Breaking the flange off the hub.
Well, if you
that,
put
that much torque.
If you put an impact wrench, you can go 1,200 foot-pounds
easy.
real quick. And
Hey, if you buy a 1-inch impact wrench, they're rated 1,700 in a lot of cases.
Oh my goodness!
And we're looking for 450 to 500.
Yeah. Well, Roger, this has been a great conversation. Thank you for joining us here on Behind the Wheels. Hopefully we can get into the show notes some links to your website with some of the information that we talked about, and we'll see you next time.
Thank you for the
Thank
opportunity.
you
Thanks a
so
lot,
much.
Roger. Really appreciate it.
Thank you.
Sponsored by Alcoa Wheels, the global leader in aluminum wheel innovation, manufacturing, and technology. Inventing the first forged aluminum wheel in 1948, its team of experts continue to develop the most lightweight, efficient, and high-performing commercial vehicle aluminum wheel products. Bringing you revolutionary innovations like Alcoa DuraBrite wheels, Alcoa DuraBlack wheels, the new Alcoa Wheels hubboard technology, and the lightest truck wheel on the market, Alcoa Ultra One 22.5 by 8.25 wheel. Alcoa Wheels, the global leader in aluminum wheel innovation.